Notacon.
Because, okay, this makes me happy in ways you guys have no idea. Because I just literally spent the last hour writing the slides for this talk. I knew what I was talking about, but I hadn't had a chance, and I'm on 3 hours of sleep. And the room seems to be moving, but I am not. And it's not due to alcohol. Okay. No, it's called sleep. No sleep. Sleep is my enemy at this point. Or my friend. I can't keep him straight. This year, were either of you at my talk last year? Excellent. You guys don't remember the horrible fiasco it was. The talk had the horrible problem of not having enough direction. So this year, I'm going to talk about how an amateur radio repeater works. How many people sitting in this room, all 4 of us, are hams? Do you guys already know how a repeater works? Okay.
Like how to use one? I know how to use
Wow.
one. You know how to use one?
You've built them. You know how to use them. Have you built one, sir?
No.
Okay. I'm going to go into the details of all the crap necessary to make one actually operate. This means I will bore you out of your mind. I do apologize. I was expecting a whole lot more non-hams in the audience, but I have the red eye session.
Would you like us to go get some?
You know, I would be amused by this, but you don't have to. I try to make my... Right. I try not to inflict my brand of insanity on those who do not wish to have it inflicted upon them. Okay, so I'm going to do my talk exactly as is. You, sir, I'm sorry, I'm going to put you to sleep. Look at it this way, you can catch up on the sleep you've missed the rest of the weekend. Okay.
Okay, yes and no.
Excellent. The audience is quickly shifting away from, everybody knows what I'm talking about, so why am I talking about it? Okay, amateur radio. If you've never heard of it, this is the 30-second variant of describing it. It's a service licensed by the FCC, from the FCC. These slides have never been edited. It took me an hour to write them. It should take me an hour to go through them, right? Okay. Service from the FCC, a interesting variation in services, because this is one of the strange ones that got put in a long time ago for various lobbying reasons, because the airwaves were being commercialized, and there was a question, where do we put the people who want to experiment? And the amateur radio service was born. It is non-commercial. By FCC regulations, I cannot accept money for playing with radios. This is a great bonus in my mind, because it's one of the many things I do which I can't get paid to do. Thus, it's a hobby. This is how you tell the difference between hobby and work. One of them you get paid for, one of them you don't. This is true. Truer than I thought. Amateur radio is really a wonderful licensing scheme, which boils down to please do not be an idiot with your radio. There are some details they put in there. They have a provision against music, which is mostly there for historical reasons. They didn't want hams competing with commercial radio stations and thus public broadcasting. You know, boring. I don't care. The other thing is, the neat trick is, hams can take any piece of hardware, paperclip, bubblegum, duct tape, glued together. If it generates RF, they can look at it, grab their test gear, say, yes, it meets spec, I'm putting it on the air. They can use anything they want. If they end up with the radio that's built out of baling wire and bubblegum, literally, they can certify it and they can put it on the air. This is exceedingly useful, as I will be getting to shortly. Okay, radios. Sir, hold up a radio, please, because I don't feel like fishing the one out of my pocket. These things are called HTs. That stands for handy talkie. No, I am not making this up. That's really what Motorola has written on the back of them. Handy talkie. Blew my mind the first time I saw it. They're common now. Everyone's got one. Really, everyone has an HT. By the way, interesting aside, if you actually own a Nextel cell phone, it's not a cell phone. It's a land mobile radio that happens to have a phone interface. Sorry. Seriously, it's licensed under land mobile radio service as opposed to the cell phone service. Yes. But that's an entirely different stuff and goes way beyond the depth of what I'm trying to cover today, because that boils down to where I'm still trying to figure it out, as opposed to what I like to give talks on, which is stuff I figured out. This makes me look a lot smarter than I am. Okay, problem with HTs, they are very limited power. Most powerful HT I've ever seen is 7 watts. And I don't want to put that next to my head, because I'd like to be able to see in 30 years. They have, accordingly, they have limited range. They have tiny little antennas on them, because you want to be able to throw it in your pocket and not have to use, is that a radio in your pocket, or are you just happy to see me as a line too often? No. They have an exceedingly limited battery life. Even the best of radios, I still have to carry a spare battery and swap it out in the middle of the day. And that's with turning on all the power-saving features that I possibly can. But I can have it with me. And a radio that is with you is much better than a radio that is not, because then you have a chance to use it. Okay, charging right along. Solution: let's stick a huge antenna with a whole lot of transmitter behind it up on a building somewhere, and listen to the little tiny radios running around, and retransmit them at 200 foot above the ground on an antenna that's 4 to 10 times the antenna that you have on your little radio at 4, 10, 100 times this power. You know, depends on what you can afford. Thus, everybody is now able to hear you, and you can work with a little HT, and you have the coverage area of easily counties. Here's what it does. This is really basic. A user transmits on frequency A. Users would be anybody out in the field who are trying to use this magical device called a repeater. The repeater sits there and listens to frequency A. When it hears a signal, it turns on its transmitter and repeats whatever it heard on frequency A back out on frequency B. All the users listen on frequency B. Here's where it gets complicated. There's a whole bunch of standard methods and frequency offsets and everything that you can remember, which make it possible so you don't have to go through and say, okay, you're on frequency 146.49, and I need to receive there, and I need to transmit over here. There's been a standardized set of rules where you can actually just specify one frequency, and from that you can determine the transmit frequency, etc. So it's all automated, which means you don't have to remember it. Okay. There's a slide in there that's missing. It went away. Oh well. Such is life. Okay, basic parts. Need 2 radios. One of them is going to end up transmitting, one of them is going to end up receiving. You need a duplexer. This is a really neat chunk of RF hardware. This is probably the coolest part of an entire repeater. I'll get into its details in a moment. You need an antenna. And the antenna that's this long isn't going to do it. I've seen it done, but it's not a very good idea. And 1 times N feet of feed line. Feed line would be what most people call coax. Though, if you get serious about building repeaters, you don't want to be using what you find running your cable television. Okay, at least, let me phrase that more carefully, because I'm about to tell you later about using it, cable television hardware. But you don't want to be using the stuff that you run cable television in your house with. Okay, I'm going to start and do it from the top down, quite literally. The antenna. This is where all of the transmission and all of the receiving is coming from. It is typically a very, very high gain antenna, which means that it... Wow. I just realized how much jargon I'm just assuming everybody knows. I do apologize. Slow me down at any time you need me to explain it. High gain antenna. Omnidirectional, vertically polarized antennas usually don't get over about 10 or 12 dB of gain simply because they get unwieldy. A 10 to 15 dB gain antenna is typically 20 foot long. Now, imagine, if you will, wrenching this 20-foot long antenna that's 4 or 5 inches across, maybe 200 foot in the air, and sticking it on top of a tower that's, well, I'm wider than the tower. They're just unwieldy to deal with at a certain point. And yes, we are putting these on as high of a tower as you can possibly find. Typical hams can't go over about 200 foot due to FAA regulations. Yes, hams do have to abide by FAA regulations as well as FCC regulations and a number of other three-letter agencies. That said, sometimes you can get really lucky and convince somebody to let you have space on their commercial tower. One of the repeaters I end up working on every now and then is located 600 foot in the air off of a television transmitter tower. It is a very, very high-profile repeater. High profile meaning you can interact with it from a very large distance away. Okay, so difference one between a repeater and your average radio. The antenna is at least 2 or 3 orders of magnitude different in size. Feed line. Coax. Everybody has plugged in a cable television, right? That's coax. Coax is great stuff. It's flexible. It's lightweight. You can put ends on it using simply a pair of pliers. It isn't enough because it loses a whole lot of signal. And remember the game here. We're trying to make it better than using your little radios direct. So every single decibel of signal that we can hang on to, we need to. So there's this wonderful invention. It's called hardline. It's called hardline because I usually like describing it this way. If you will, imagine a very thin copper pipe. Thin-walled copper pipe, about 1.5 inches around, with another very thin-walled copper pipe running down the center of it. Now try and bend it in a circle. This is what's called bend radius. Bend radius on the hard line I use, well, tight as possible, the roll's this big around. It's heavy. Like, you actually have to count pounds per foot and make sure that you don't unbalance the tower and have it fall over on you. This would be bad. It's no fun. It's bulky. Like I said, it bends this big around. That's it. It doesn't go any tighter. It's expensive. You're looking at $4 to $6 per foot if you buy it new. And remember, your antenna is 200 foot in the air, and unless you feel like hauling all of the other crap up there, your radios are sitting on the ground. So this is 200 foot of feed line. The only reason we use it, it has a much lower loss per foot than any other thing out there. And you can get hardline. Hardline starts at about a 1/2 inch and works its way up through about 3 inches. So that's 3 inches across. That stuff is unwieldy to deal with. Much lower loss. This is the only reason you use it. We hate it all, and we have to use it all the time. Added fun. Yes. Hardline connectors, as in the thing you put on the end of the wire to turn it into something that looks like an RF connector. Say, N, BNC, TNC, any of these other various connectors that you might be familiar with. Those are often running on the order of $200 for one connector to put on the end. Thankfully, hams are resourceful, and we can look at anything and say, yes, that meets regulations. There are all sorts of neat ways to generate your own connectors, and more importantly, use the cheap hardline that you can wander over to your cable TV company and say, hey, can I have some of your short ends of hardline? And cable TV companies, their definition of short end is anything under a quarter mile. That's a short end. Okay, I'll get a trailer. I'll take them. I'll take them all. I literally did this. $15 for a half-mile worth of short ends. Because they don't want to use them. They don't have a way to get rid of them. Your cable TV company can be your best friend, your worst enemy, and a good buddy all rolled up in one. Okay, charging right along. Some are buried, some are strung aerially. I have some of each. It's actually the same stuff. They just stuff it in the ground sometimes. Yes. And they usually use something called 7/8 inch, which is enough. The only reason you would dare use it is because it was free. And, well, I'm cheap. And it's effective. Okay. So, if you've ever played with radios, and you're sitting there and you have two radios in front of you, and you transmit on one, all of a sudden, if you were listening to something on the other one, it goes away. This is called desense. This is because the amount of transmitted power is so overwhelming the receiver on the other one that it can no longer receive the signal that it was trying to hear. Now, imagine trying to transmit and receive on the same antenna rather than one that's a foot apart. This is a n-squared problem. Further you get apart, the less power there is. And eventually, after 4 or 5 foot with little HTs, you can once again hear it. The distance is 0. I'm transmitting and receiving on the same chunk of wire. Thus, we're inventing these wonderful things called duplexers, or cans, or resonators. They're called cans for one reason, is it looks like 4-inch wide soup cans. That's just what it looks like. They come in various sizes. They are band specific, so if you are working on 50 megahertz, i.e. the 6-meter band, you will find cans that are as tall as I am, because they need to be a quarter of a wavelength long. If you are working up in a sane and reasonable band like 440 megahertz or 70 centimeters, you will find cans that yay tall. If you start stealing stuff out of cell sites that you've purchased and retuning them into the 900 megahertz band, they're tiny. And it goes down from there. Okay. They're tuned cavities, which means that there's a chunk of metal that you can screw up and down inside the middle of this, which resonates on one frequency. And since it resonates on one frequency, that is the frequency that goes in one side and comes out the other. And all the other frequencies are rolled off, and you can't hear them as much. This is very much like if you've ever played with a DJ mixer, the mid-pass setting. Excuse me, the voices in my head are getting to me. If you've ever played with a DJ mixer and you grabbed the mid knob and you tuned it back and forth and you heard different ranges of the mid-tones coming back through, this is what a can does for RF. Now, since you have that ability, go. Yes, which is an advantage for reasons I will get to shortly. So I can tune it on one point. Most cans also have something called band reject, which is an anti-resonator, which means I can say, pass this area, but really don't pass this area. So with the typical setup of 4 cans, which is 4 resonators, 2 on the receive side, 2 on the transmit side, I can put enough separation between the two that I can receive on one frequency and transmit on one 5 megahertz up, and they don't see each other. The transmitter is not feeding into the receiver because the receiver CAN pass is specifically set up to reject everything from the transmitter. And the transmitter, we usually tune it this way, but there's no reason to, rejects the receiver's frequency all the way around, which has the added bonus of when we're transmitting out, if there's any problems with the transmitter throwing out energy on the received frequency, the cans cut that frequency out as well. This is straight up frequency division multiplexing. This is one method of doing it when you have a single antenna. This is not how your cell phone company does it. They have an entirely different method. And modern cell phones go off in an entirely different direction. But we're not talking about cell phones, we're talking about amateur radio. Okay, I'm not understanding the question. This is probably because I'm half asleep. Oh, the tolerance. I'm going to be honest. We don't care. We tune it to the center. Okay, it's wide enough to pass a narrowband FM signal through, which means it goes 5 to 10 kilohertz each way with an acceptable roll-off, with effectively zero roll-off. We don't care past that point. I have cared. I need to sit down and do those numbers for any given model, but it varies by model. Usually, the first response to your question would be about a quarter turn, which is how far I have to turn it before it falls way out of alignment. Now, no, tuning cans is a process of taking a screwdriver, putting it in a slot, staring at a monitor, lining it up, pulling the screwdriver off, getting a readout, putting the screwdriver back on, guessing, pulling the screwdriver off, seeing if you guessed right, doing it again, and this can often take hours because you have 4 of these to do and they interact with each other. So you don't actually tune it correctly, you tune it to within epsilon of correctly, and then you walk away, lock it down, and pray the temperature doesn't change on you. It's called a repeater shed and a heater. And if your repeater is in heavy use, the repeater will heat itself, because it's going to be dumping a whole lot of waste heat. They all, after a certain level of repeater, they all dump waste heat. Okay. Hello. We would, except that we're out in the middle of nowhere where I do this stuff, because for some reason municipalities, people don't like seeing 200-foot metal structures rising from the side of people's houses. I think they're beautiful. I don't know what their problem is. Okay. Why? I am being failed. This probably means I can't edit a text file this morning. Okay. Radios. These are the last components that you desperately need to make this actually happen. You need 2 of them because, like most radios, they can either transmit or receive, but not both. And now you have to do it at the same time. Here's where it gets fun. Grab the busy light off the radio you're using to receive, tie it to the line marked push to talk on the radio you want to transmit on, and you have a repeater. It's not legal. It's got some major details missing, but it will work. We have done this for testing. Don't try this at home. Understand what you're doing in advance. Now I'm going to yammer on about radios. So we need 2 radios. One of them only receives, one of them only transmits. This means that you can now specialize your radios to one purpose, rather than having a transceiver that needs to do both, because you're going to key down, talk, unkey, and wait for somebody to listen. You can go get a high sensitivity receiver and put it in for the receiver role, and all it has to do is receive. In the same sense, I can go get a very high powered transmitter that has no receiver stage on it and use that. Our personal favorite right now, we like taking what used to be paging transmitters and turning them into amateur radio gear. I'm staring at the time. Okay, I have enough time to make a side story. Side story. I get a call one day. Hey Jeff, would you like to go pick up some radios with me down in Detroit? I live in Lansing. This is about an hour from Detroit. Sure, when are we leaving? Saturday morning, 6 a.m. Why do you guys always do this so early? Well, come on, get up. We get up early. So I do it. I dive into the vehicle. And I get there. And we go over and we pick up the truck. with the trailer attached. At this point, I realize I'm getting in over my head. We drive down to a paging company in Detroit's site, where one of our contacts has been very carefully scavenging paging hardware that has to be thrown out and placing it so that we can park our vehicle next to the dumpster and miss. That day, I personally moved 3.5 tons of radio. I was hurting. Excuse me for a moment, I need water. Okay, so 3.5 tons of radio. This was in the form of 17 racks, each one weighing 500 pounds, which was an entire paging site that got ripped out of some county in Michigan because they were all upgrading to 900 megahertz, so we were getting all of their 70 centimeter gear, or as they call it, 460. Well, you grab the knob and you twist it, and, hey, that's funny, it goes down into the ham band. Great! 250 and 350 watt paging amplifiers. They're designed to run 24 hours a day, 7 days a week, until they run out of power. Or the universe collapses. One of the two. We got these for a song, a dance, and an agreement that we would turn them into amateur radio gear. This is how you do radio on the cheap. You find friends in the commercial communications industry and say, hey, I know you're throwing stuff out. Oh yeah, as a side effect, that 3.5 tons of radio, and another 500 or 600 pounds of hard line, and forklift load of cables, connectors, parts, adapters. You walk into a ham shop and there's $3 an adapter. I get a shovel out and I just shovel them. It was that bad. We just had a shovel and we were moving them because they were all laying on the ground, and it's sort of like, yeah, just pick those up. Pick them up? Are you nuts? Got a shovel out and just shoveled them all into the truck. And this guy, when he says, take it, you don't ask what it is. You don't wonder if it's worth taking. You just pick it up, throw it in your truck. It's out of his hair, and now you get to figure out what it is. Which is another interesting story of the cell site that showed up at a friend's house, but we'll be going, if you want to hear that, talk to me later. Okay. Aside complete. I hear a question. I hear a question. Does anyone find this, would anyone find it useful if I made a random diagram at this point? Big blocks, lines between them. If anybody wants me to, speak up now. Otherwise, you aren't going to see that I can't draw. Details. These are all the other pieces that you desperately need to make this actually work in a way that doesn't suck. There's this invention device object called a repeater controller. Its job is to, rather than wire the busy light from one radio and into the transmit button on the other one, and then you just connect their audio, its job is to process this audio and do sane and reasonable things to it. It can do useful operations like put your FCC mandated call sign on the air every 10 minutes like you have to. This way you remain legal and the FCC doesn't come knocking on your door with a bad attitude. It can do things like shut down half of the repeater so that it no longer transmits because it's decided to do something horrible and wrong. You have to deal with it. It can interlink audio from multitudes of repeaters to each other, which is a neat trick, which allows you to do things like link to other repeaters. So here's one repeater, and I can now teach it to link to another repeater, and now you have two repeaters that are sharing the same audio, sharing the same information, and you've just doubled your coverage area. This is one of the repeater networks I work on, which is slowly consuming the southeast, now moving towards central and northeast sections of Michigan. We can with a little cheat sheet where we write down all the frequencies, wander anywhere from Detroit to Eagle. Detroit to the west side of Lansing, grab an HT, choose a channel, and we are on the same repeater network talking to the same group of guys. And you just, as you're driving, you just pop channels, find the next one, keep moving. They also have neat tricks like our repeater controller at the main site now has a door sensor on it, so it can tell when somebody opens the door, and then it starts screaming, "The door is ajar. The door is ajar." It does this every 45 seconds until we tell it to shut up. This is designed to annoy anybody on the repeater, so if somebody does, in fact, break into the repeater, there will be somebody out there to investigate shortly. It also has some other neat things like, "The repeater is on fire," which we wired into the smoke alarm, or "No power," which we wired into the power sensor. The repeater will continue to operate even if we lose main power for roughly 40 minutes before we run out of battery on the UPS. That's the time frame that one of us has to get there to walk over to the 10,000 watt gen set setting next to it, yank the pull start on it, plug in an extension cord, at which point it stops whining. Wow, I made slides. I don't even remember making these. Okay, polyphasers. These are lightning arresters. We have just put a lightning rod in the air 200 foot up and are now asking for it. Trees are nothing compared to this. I have just put a grounded superstructure 200 foot in the air and then stuck a chunk of metal on top of it. Yes. Yes. A point right up at the top of this. You are asking to get hit by lightning. Well, we know every time our repeater gets hit by lightning because we hear "controller rowdy," and the thing resets. We can sit out there during lightning storms and listen to it go, "Ready." Wham! Ready. Is that what I thought? Wham! Ready. Yes, that was exactly what you thought it was. Repeater gets hit by lightning all the time. You just have to engineer around the fact your repeater is going to get hit. This is what polyphasers were invented for. Polyphasers are these wonderful little devices which you put inline in your coax, inline in all of your control signals, and inline anything else. And when they see the, several, I'm trying to think, billion, million, yeah, somewhere in that volt spike from lightning come at it, it jumps to ground and sends the lightning down to the path it wanted at the ground, as opposed to ground through your extremely expensive gear that you scavenged. The only time this doesn't work is when the lightning chooses to strike a direct strike on your antenna, and your antenna decides to vaporize. I've had this happen. I've rebuilt the station after it. It took a lot of damage. The polyphaser saved the expensive stuff. We actually had pieces of the antenna found a quarter-mile away by an engineering student going, "What's this?" Walked into class, his professor said, "That was the antenna that was on the roof." "What do you mean?" "It got hit by lightning the other day." And same night I was over there looking up saying, "Well, okay, we are in Michigan, and it is in the middle of a thunderstorm, and the clouds are dark, and the antenna is gray, but I don't see our antenna up there." So I walked around the other side of the building. Still not there. Grabbed my camera with the zoom lens, zoomed in on it. Well, there's a bird sitting on the little radio to dissipate static electricity, but there's no antenna on top of it. This explains a lot. This was a very long day. Anyway, polyphasers. Get them, use them. They're expensive. They will save your more expensive gear. Test gear and jumpers. Remember my story of shoveling connectors? And, well, although it seems tempting to, don't use a pitchfork on the stack of jumpers that you need to use, because you will go through the jumpers and then you will be very sad. This is part of the adapter conspiracy. Everybody chooses a different standard to put on their equipment. Some people use BNC, some people use N. These are two of the sane and reasonable standards. It's when you start hitting TNC, reverse polarity N. Let's see, there's SMA, there's half a dozen others. I have a $100 set of everything to everything, so I can generate a reasonable cable or a reasonable adapter when I end up desperate hunting for a wire. It's expensive. You will be going through adapters like crazy if you ever get in this. You will collect literally pounds of adapters that you will have to have on hand when you're working on the repeater, because no matter what happens, you will not have the adapter you need on site unless you have all of them with you. The other wonderful toy, which I assure everybody that gets into radio needs to at least play with and have a friend who has one, if not own themselves, is a service monitor. How many people in here have ever played with a voltmeter and knows how it works reasonably enough that they can test a battery with it? Excellent! Okay. The service monitor is that equivalent for RF, except it also includes all the other options on your voltmeter that you've ignored from day one and still don't know what they do. I honestly don't know what some of them do. The service monitor allows you to do a frequency analysis, see where your repeater's actually transmitting, see if it's transmitting in places it's not supposed to be transmitting, generate test signals into your entire setup. I use it for tuning cans when I don't feel like tuning with a live 300 watts of power behind me, because if it arcs or I do something wrong, the power might come out and touch me, and I don't want that experience. You can feed a test signal in one side and get a frequency representation out the other, and see where it is peaking and where it is low, all that other fun stuff. Very neat toys, very expensive toys. Consider it about the cost of a reasonable used car. And the worst part is, you don't need only one, you need two, if you're going to be staring at 2 test points in the network. Anyway. Community! Yes, community through technology. I had to throw this slide in here for fun. For those who want to learn how to do repeaters, and you're like me and poor, the best option you have is to find an amateur radio club that has a repeater, and there's a guy who's willing to teach you about it because he doesn't want to do it anymore. You will end up learning more about running a repeater in the first 6 weeks of having to do it than you will ever do so by actually reading a book on the subject. I should point out, I don't know of any good books on the subject because I learned through the immersion method called "Get This Done Now or You're Not My Friend Anymore." Huh? No, just kidding, kid. Figure it out. Right. I don't know of any good books on the subject. I wish I did. Best thing, find somebody who knows what they're doing. Get them to teach you. Usually the best way to do this is by being free labor to move the heavy stuff for them. Because, as I alluded to earlier, yes, ham radio is a move heavy stuff hobby. Makes photography look downright simple. Other bonus, if you work on somebody else's hardware, this means you don't have to buy it, and when it breaks, they may blame you, but they probably won't hold you financially responsible. This is wonderful. This allows you to experiment and learn. And if you come up with a harebrained wild idea to try, and you bounce it off the guy and says, yeah, go do it, now you've just pulled off something silly. My personal favorite story about this, so one of the groups I work with, we all have Nextels. This is because we all ended up with Nextels for one reason or another. Everybody who has a Nextel knows its sound. You all know it from the commercials. Well, I figured out how to contort our repeater controller into playing back an arbitrary audio file as its courtesy tone. A courtesy tone is at the end of the transmission, you on key, and the repeater goes beep, and you know you can then start speaking again. It forces you to slow down, because otherwise you go at 1,000,000 miles an hour. So what we did was we re-recorded the Nextel chirp thing from Direct Connect and played that as the courtesy tone. This got everybody amused, but what really ticked them off is when we re-recorded the battery low warning and used that as the courtesy tone. It caught me, and I'm the one who did it. I'm going, what do you mean battery low? Picked up my Nextel, and then I look, oh crap. We had fun with this for nearly 3 months, changing the courtesy tone to anything we could come up with, including various people on the repeater going beep. So the repeater did not go beep, it said beep. We did have the Roadrunner for a while. Meep, meep. And it goes off. And we never did real barnyard animals. It was amusing. I twisted the controller into doing this. This is not covered in the manual. This was just a realization. You know, if I hook these 3 parts together, okay, cool, try it. Various groups I have hung around and spoke with. ARPSC/Alcedra. Welcome to acronym PAIN. That is the Amateur Radio Public Service Corps for Ingham County, or the Lansing Civil Defense Repeater Association. And since essentially all of the members are the same people, I like slewing them together when in fact they are entirely 2 separate processes with 2 separate organizations and 2 separate sets of politics. They run 4 repeaters in Lansing. If you want to work on a repeater, you go to the meeting, you sign up, you pay the $5, and then you volunteer to fix the repeater with the guy who actually maintains them. This lets you into various interesting places because, of course, all of these repeaters are hosted in the maintenance areas of hospitals, the roofs of various buildings, or on the side of 1,000-foot towers, which happens to have your local 60,000-watt radio station sitting right next to your little amateur radio repeater. So if you like staring at oversized stuff or enjoy touring data centers like Level 3 or something like that, playing with repeaters will get you to the strange places to run into these oddities. And you can go, whoa, cool. Anyone looking at it? Grab your camera, shoot pictures of it, and show your friends, look at what I saw. Seaman. Yes, the name was chosen for the exact reason you're thinking. Get your minds out of the gutter. Ours were there. Southeastern Michigan Amateur Network. This is the group of guys that I learned how to run repeaters with. It is an entire... Okay, ARPSC and Alcedra actually has meetings with agendas, with rules of order and voting. Seaman, we have 1 meeting a year. Is this still working? Okay. We have 1 meeting a year before a yearly ham swap in a little town called Marshall, where we have breakfast. That's the meeting. We have no rules, no agenda, no order. All of the hardware is independently owned and operated, and we all just link it all together. This is done ad hoc at best, and sometimes using ideas in ways that fall under the category, do not try this at home, do not try this at work, do not try this. We are we are amateurs. We know what we're doing. This is a lot of fun because you can do... Really, sir? Really? I think I see a clock here. Thank you, though. This is a lot of fun for the simple reason that you can do stuff which anybody else in their right mind would tell you, no, you can't be done. Working on this repeater says, okay, backing up. You guys remember me talking about descents just a few minutes ago. Turn on one transmitter. Receivers nearby can't hear it. Use duplexers. You can now hear something. Okay, so if I want to link from a UHF repeater to another UHF repeater, most people tell me it can't be done because the transmitter from your local UHF repeater will wash out the link to this remote repeater. That's a lie. You can do it. You just have to be insane and put more duplexers in line and turn them into a chain of 4 and tune out the repeater. All of this stuff is entirely possible. Common statement is it can't be done, but if you have a group of guys like this who will say, what do you mean? Let's try it. And surprisingly enough, things work. We still have to explain to people that, yes, really, sir, there are 11 repeaters in this network. So when you say, where is the repeater, you're going to have to specify what frequency you're using. Well, how big is this link? Michigan, sir. Oh. But I'm using UHF. Yes, sir, our UHF repeaters reach out 30 miles. I thought UHF was only good for 2 miles. No, sir, that was your UHF repeater. This is ours. The last one I'd like to talk about is the link. I have almost nothing to do with these people, but they are the diametric opposite of Seaman. There is a organization, there are meetings, they have planning committees, they go out and they generate architecture and documentation and all this other stuff. We don't document anything. We put it together. We figured if it was hard to figure out, or if it was hard to put together, it should be hard to figure out how we put it together. We leave ourselves little cryptic notes so that when we get there we go, I remember this. I wrote this note. How does this work again? The link, you will find reams and reams of documentation. It is all crisply put out, explained, and how it will work. And then it occasionally does. Okay. I'm going to stop now and ask for questions. Anything on the topic of amateur radio is up for grabs. I only mumbled about repeaters because last time I didn't have any guidance as to what I was going to talk about and asked for questions, and nobody had any. So, amateur radio, anything. 5 minutes, guys. Fill 5 minutes of my time. Go for it.
On the subject of repeaters, how much trouble do you guys have in reaching?
Huge. 3 years wait.
I've been waiting for a repair since I've been licensed.
I'm sorry, sir. This is going to sound really silly. Move into the sticks. We are running repeaters from 6 meters up through 2.4 gigahertz. We link them all together. So I think we have one repeater on 6 meters that we link into on a regular basis, and the guy's cool with that. We have 3 or 4 repeaters on 2 meters. We have 5 or 6 repeaters on 70 centimeters. We have a small handful of repeaters on 220. We're 220 support. We have 900 megahertz stuff expanding. We have one guy with a 1.2 gigahertz repeater and one guy with a 2.4 gigahertz repeater. And we link them all together. So it's one big happy party line.
One thing I was concerned about what you were before, the repeaters that exist in those bands in New York have one user, which is usually better for
Motorola. We mutilate Motorola gear. We are very, very happy to take Motorola hardware and turn it into something useful. And essentially all of our repeaters, all of the hardware surrounding the RF stages is Motorola gear that we've stripped out of a cell site somewhere, or a paging site, or this site, or that site, and got for cheap because we hauled it away by the pound. And then we figured out what was useful in it, turned as much on as possible, and eBayed the rest.
Question. Duplexers, I assume you said those are all done in the shack bottom of the tower.
Typically. You can put them anywhere you want between the radios and the antenna, though for reasons of sanity and economics, it makes sense to put them down in the shack and run one piece of coax up the tower as opposed to 2. You can use the heat in the wintertime. They're usually efficient to half a dB of loss per can. this is okay, but you have to make sure your cans are rated for the amount of power you're dumping into them, because this means they're also rated to disperse or otherwise dissipate that much power. Added bonus of using the cans, which I forgot, they act as polyphasers. So when lightning hits your coax and follows down, if you have a set of cans in line, they act exactly like a polyphaser and shunt the lightning to ground, as opposed to shunting to ground through your radio. Yes, we do it all the time. We have scorch marks on them. Just paint over it. Nobody will know.
How are the cans connected? Is there like a big lead? Because normally it would be like you don't want to...
Jumpers. Lots and lots of jumpers. If you have a 3-inch chunk of hard line, it comes down to the bottom of the tower, and you have a connector there, and then you have a jumper from it to the shack, which is the radio shack sitting at the bottom of the tower, which has a plate on the outside which has your polyphaser in it, which is big chunk of metal, which is then dragged back to ground. Goes through that chunk of metal plate. There's another jumper inside which takes it to your cans, and from that it then is taken out through more jumpers to all your radios. Yes, though that is built into the pack of cans that you find.
Okay, so they usually come in a 4-pack.
It comes in a 4-pack and a 19-inch rack mount that you can screw into your favorite rack, and there's a Y built in there that's already tuned up. You end up with 2 cans on the left, 2 cans on the right. Yeah, you got it.
That's the really hard piece to get your hands on. That's from what I've seen. Well, other than the 200-foot tower.
With enough money, it's really easy. This is the challenge, to do it on the cheap. The other point I should make is that if you're creative, you can rewire cans into things other than duplexers, like triplexers and quadplexers, and this can be useful occasionally if you have some reason to triplex an antenna. The mechanical example I have, excuse the pun, is when I'm setting up a linking radio on UHF, on a UHF repeater. We just triplex the thing. We'll use one antenna up there, 3 frequencies at the same time. Okay, I was out of time a minute ago. I'm going to be around here somewhere for the rest of the day until we officially declare this over. And if you have an interest or a question, or I didn't cover something in detail enough, let me know. I'll try and make something up. Thanks, guys.